So in the last two videos, we introduced the inverse trig functions, talked about how we can solve some equations that are presented to us with them. Each of those videos had nice angles, angles that relate to either a 30, 60, 90 triangle or a 45, 45, 90 triangle. This is probably something that you'll do a decent amount of as well. So if you look at what we've got going on here, we've got this triangle given to us, and they tell us that lowercase f is 17, and notice lowercase f, and this is pretty common for trig textbooks to do. Lowercase letters represent the side lengths, and then you'll notice the capital versions of the same letters are the opposite angles, right? So opposite lowercase f, we see angle capital F. Opposite lowercase d, we see angle capital D, and then opposite lowercase e, we see angle capital E. So they give us lowercase f, which is 17 units. They tell us lowercase d is 32 units. What they ask us to find here is they ask us to find capital E. So they want us to find angle E. So what we're going to have to do is we're going to have to try to think about what we can do to determine this. Now we know that this is a 90-degree angle. If we were given what angle F measured as, we could just use the fact that all of these angles have to sum to 180 to find angle E. You've definitely done that in geometry. That's not something that we can do right now because we don't know capital F. So to find angle E, we're going to have to do something that relates what we do know. We do know that it's a right triangle, and right triangle gives us the green light to use SOHCAHTOA, to use right triangle trigonometry. We are given side F and side D, right? I've already got them labeled on the triangle. So if we want to know angle E, and we know lowercase f, lowercase d, let's think about the relationship between the angle that we want to know and the sides that we do already know. This is pretty clearly the hypotenuse of the triangle, this side D is. So we know the hypotenuse. In relation to angle E, what's this side F down here? Well, it's definitely not the hypotenuse. D is the hypotenuse. It's not on the other side of the triangle. It's not opposite angle E. It's along angle E, and it's not the hypotenuse. So it is the adjacent leg of this triangle. So if we want angle E, we know the adjacent leg to angle E and the hypotenuse of the triangle. Which of the three pieces of SOHCAHTOA involve the pieces that we have access to here, the adjacent leg and the hypotenuse? That would be the cosine ratio. So if we set this up, cosine of, and the input to a normal trig function is always the angle that you were referencing. In this case, it's the angle that we're looking to find. So cosine of capital E is going to equal adjacent, which measures 17 units, divided by hypotenuse, which measures 32 units. So cosine of angle E is equal to 17 over 32. Now what we want to do is we want to figure out what angle E measures as. Now we are going to be measuring our angle in degrees here. This is not a situation where I see some form of a fraction here that involves the values from a 30, 60, 90 or a 45, 45, 90 right triangle. So I'm not going to try to do this without a calculator with the unit circle like we've done in some of our other videos. This is definitely something where either a trig table, more likely a calculator, either scientific or graphing calculator, is going to have to help you get that answer. To isolate capital E here, what I'm going to have to do is I'm going to have to undo the cosine function. What I use to undo the cosine function is the inverse cosine function. So when I apply inverse cosine to cosine, they cancel with each other, and I'm just left with capital E. And then in my calculator, I do have to double check, make sure that I'm in degree mode. You might be measuring in radians. Just kind of pay attention to what your book, your professor is asking you to do. Right now, ours is asking us to deal with degrees. So we got our calculator in degree mode, so we've double checked that. Now we're going to fire in inverse cosine of 17 over 32. So inverse cosine above the cosine key. So inverse cosine of 17 over 32. Close that set of grouping symbols that it gave us. And there we go. I rounded that to the nearest tenth, so 57.9 degrees. In the next video, we're going to do something known as solving a right triangle.